Well, hey everybody, hope you're doing well. Sorry about the last video. I didn't realize, I think I had the wrong camera chosen. So let's see if we got the right one. I think this is the right one. I'm going to stick on here just to make sure. Yep, there it is. Okay, so anyways, we're going to dive right into 1.3. So I apologize before we even start. This is a lot of vocabulary. So, vocabulary is important in math because you have to make sure that you understand what you're talking about and it makes sense and things like that. But there's just a lot of vocabulary. So we're talking about classifying numbers and graphing them. We're talking about inequality symbols, additive inverses, absolute values, and then we're going to look at some real-time table of data just to see what things look like. So hopefully that makes sense. Like I said, I apologize. The nice thing about the video is that I'm going to go through the vocabulary stuff a little bit quicker than I probably did in class. So if you guys want, go ahead and pause it, write down, take notes, whatever you need to do, all that fun stuff. So the first thing we're talking about is we're going to talk about classifying numbers. And the first set of classification that we're going to talk about is a thing called natural numbers. So another phrase that I know about natural numbers, and the reason why we need to talk about vocabulary is because throughout the semester I'm going to be using these kind of terms to go over things, so hopefully that makes a little bit more sense. So natural numbers, I think of counting numbers. So if I had like a couple pencils, and I asked you to start counting them, you wouldn't start at 0. You would start by counting 1, 2, 3. Right now my son is learning how to count, from 1 to 30 or whatever. So he always starts with 1, 2, 3, 4. You never start at 0. So that's what these natural, that's what the natural numbers are, and then whole numbers include the number 0. So if we're talking about like the first set of numbers, we're going to talk about natural numbers, counting numbers, and then the second one is our whole numbers because they start at 0. So the third set that we're going to talk about is something called integers. So integers are going to be those natural numbers, which are 1, 2, 3, 4, 5, up the whole number 0, 1, 2, 3, 4, 5, and then now we're including also their inverses, or the opposites as I call them, also known as integers. So if we're looking at this number line here on the screen, 0 is right in the middle, positive numbers are always to the right, negative numbers are always to the left. The interesting thing about negative numbers is that, you start at 0. If you go the one way, you're going positive numbers. You go 1, 2, 3, 4, 5, but then when you go negative, you actually start with -1, -2, -3. So in that sense, you just have to think that like a number like -5 is actually smaller than -3. We'll get there. Hopefully that made sense, but it's just the fact of, and I think about it, I compare it to money. So like if I have -$5 in my bank account, that means that I have less money than if I had -$3. I know that sounds weird, but hopefully that helps. And then, so another thing we're talking about here is something called the additive inverse. So basically the additive inverse, and I kind of already used this terminology already, but if we're talking about the number 1, the additive inverse would be -1. Because if you take 1 plus -1, you get 0. So another way to think about it is, I think about the opposites. That's one way to think about it. Another way is just, you can talk about just thinking about like if I were to add them together, what would get me 0. So those are just kind of like the word additive inverses and opposite I'll probably interchange, so hopefully that makes a little bit of sense for you guys. So now we're talking about finding the additive inverse. So the additive inverse of a non-zero number is found by basically changing the sign. So for instance, if I have this list, the additive inverse of a +7 would be a -7. The additive inverse of a -5 is a +5. 0 doesn't have an additive inverse because you're already there, so that's just going to be 0. And then the neat thing is you can also use these with fractions and decimals, so it's like a -4/5 is going to be 4/5. I'm sorry you can't see this, but it says 0.064, so that's going to be -0.64. So hopefully that makes sense. So you're basically just changing the sign. Again, you can think about it as opposites, or you can think about it as, what do I need to add to this to get back to 0? Hopefully that makes sense. So the first thing we're going to talk about is, it says use an integer to express the number in boldface italics in each statement. So Erin discovers that she spent $53 more than she had in her checking account. So the question you're asking yourself, is that a positive 53 or is that a negative 53? I think we can all agree that that would be a negative 53. The record high Fahrenheit temperature in the United States was 134 degrees in Death Valley, California on July 10th, 1913. So if we're talking about a high temperature, are we talking about a positive 134, or are we talking about a negative 134? I think that we would agree that that is a positive 134. Classifying numbers. So remember, we talked about natural numbers. So those are 1, 2, 3, 4, 5. We talked about whole numbers, which includes 0, 1, 2, 3, 4, 5. We also talked about integers, which includes those both 0, positive numbers, and negative numbers. So then we're going to talk about this idea of rational versus irrational. The way I think about it is what I have down there in bold. So there's the technical math term for it. So again, pause the video, write it down if you want. The way I think about it is rational numbers repeat and they also terminate. So a rational number might be, an example would be 1/3. Because that's 0.3333, right, forever, right? And this repeats, so that's rational. Terminating as well. So let's say 1/4 is 0.25 because that terminates. That's done. There's nothing more. It's just 0.25 as a decimal. You can't go anymore. So those are rational numbers. Whereas the most famous irrational number is what I think of as pi. So that is 3.14159, and it keeps going forever, right? It doesn't repeat. These numbers, there shouldn't be one there, but these numbers never repeat. If you look up pi on Google, you'll see there's no repetition at all. They keep going forever, and it doesn't terminate. It keeps going on forever and ever and ever. So most of the time, your irrational numbers are going to be square roots of, like, prime numbers are always going to be. Remember, prime numbers are ones that only have factors of 1 in itself. Besides pi and square roots, that's pretty much what you're gonna get. I mean, unless you have like some decimal like 1, 4, 2, 7, 5, 9, or 8, 3, like unless you have something like that as well, that might be, but I don't know. Okay, so graph these ones. So I want you to pause the video and see if you can graph these on the number line. These are both. We've got some whole numbers there. We've got some rationals. We got some irrationals. We got some integers. So go ahead and take a second and pause the video and see if you can graph these on this number line. Okay, so the first one we're going to talk about is -2.5. Now be careful here. This is where you have to think about it. It goes there. If you put it between -1 and -2, that would actually be -1.5. So that's, again, you kind of have to like. I know it's weird because like 2.5 on the positive is between the 2 and 3. So -2.5 would be on the negative between -2 and -3. Hopefully that makes sense, and we'll see. 0 is kind of nice right there in the middle. 7/4. If you guys can't recognize that 8/4 is 2, you can change that into a decimal. Whatever you need to do, like I would change all these into decimals and then graph them from there. So 7/4 as a decimal is going to be 1.35 or 1.75. So you just want to be able to, it's past halfway between 1 and 2, but it's about halfway between halfway and 2. Hopefully that makes sense. -1.4 is just a little bit to the left of -1, and 2/3 as a decimal is 0.666666 repeating. So you're going to want to put your decimal right there. So hopefully that makes sense. Hope you guys are able to do that. So what does this look like in a picture? This is what it looks like. So we have our natural numbers there in the middle and the smallest. And then the whole numbers are all the naturals plus 0. Integers include the naturals, the wholes, and now we're including negative numbers. And rationals include those terminating decimals. So again, -9/2 is really -4.5, terminates. 7.1212121212 repeats, so that's why it's rational. 11.23 terminates, rational. 3/4, 0.75 terminates, that's why it's rational. Okay, or if you look at the other ones, 2.71828, blah, blah, there's no repetition there. Irrational. Pi, irrational. Square root of 2, irrational. What makes all of them up is this idea of real numbers. And in this class, we're only going to talk about real numbers. There are non-real numbers. We're not even going to touch it. It's not even going to get close to it. We're just going to talk about real numbers in this class. Hopefully that makes sense. Okay? All right, so now that you have that picture, I would even like take a screenshot of this, take a picture of it with your camera, whatever you need to do. This is kind of the idea about classifying. This is like the overall end-all be. So now, sorry, this is backwards, but they want you to list these in what sets they are, and for some reason they're already written out for you, so I'm just going to show it. So whole numbers are going to be 0. That's the only one you have up there, because remember, it's only like whole numbers. So -5 would not be 1 because that involves the integers. But remember, because whole numbers are part of integers, right, back from our last thing, that's why -5 and 0 is going to be on there. Rational numbers are going to be all those because -1 and 3/5 is -1.6, terminates, it's rational. 0.45 repeating, it repeats, rational. 5/8 is going to be 0.625, terminates, rational. The only one that's not irrational is going to be the -pi, which you can't have a -pi, it's just -3.14159, whatever. And then the square root of 11, which I have no clue what it is, but it's going to be irrational because 11's prime. Okay, so hopefully that makes sense. Hopefully you're getting an idea of what's going on here and all that good stuff. Let's talk randomly about inequalities real quick. And this is maybe I should move this forward, but determining whether -4 is greater than -1. I think it's easier if you see it on a number line. Now, again, this is what I tried to say at the beginning of the video. You kind of have to take a step back and say to yourself that yes, 4 is greater than +4 is greater than +1, but -4 is not greater than -1. -4 is actually less. And again, think about your bank account in your pocket. If you have -$4, you would have less than if you just had -1 in your pocket. Hopefully that makes sense. The final thing we're going to talk about is going to be absolute value. So the absolute value, the thing that I love about this is this part right here. It is the distance between 0 and the number on a number line. So when we're talking about absolute values, we're just talking about that. How far is it away? So it's kind of like the additive inverse in a sense. But let's look at some values again. Pause the video if you want to write that down. That's very mathy for me. I don't like the mathy stuff. Yeah, it gets kind of confusing. So here, the key here is you have to bring back that PEMDAS stuff that we've already talked about here and see what's going on. So the absolute value of 32, how far is 32 from 0? 32. How far is -32 from 0? We would also say 32. This one's a little bit tricky because you always do absolute value. You treat them like they're parentheses. Remember we had our PEMDAS. Sorry, I should be using my pen. Remember we had PEMDAS here. And so we treat them like they're parentheses. So they're going to do that first. So the distance from -32 to 0 is 32. But then I basically have this. So that's why I'm going to have a -32. So that's just trying to throw you off a little bit. And then finally, you do the absolute value first. So 32 minus 2 is 30. How far is it from 30 to 0? 30. But then you're going to put that negative out front. So hopefully that makes sense. Okay? The final thing we're going to do today is we're going to talk about this chart. In the table, which category represents the greatest % increase from 2013 to 2014? So what I know first is I know that I'm looking at this column, right? Because the other one's from 2014 to 2015. That's not really what I'm worried about. Okay? So the greatest % increase. Well, there's already one I can eliminate. And that would be the bottom one. Because why? Right. It didn't increase. It actually decreased. So we can get rid of that one. So now we're looking for the biggest one we can. So again, we're looking at this column. I believe the biggest number we have there between the 0.1, the 2.3, the 2.6, and the 2.4 is going to be the 2.6. So which category represents the greatest % increase would be housing. Okay? So I know that was a lot. The biggest thing you can take from this is really that chart where it had real numbers and it had those circles. If you guys can get that in your brain, write it down, copy it down, take a picture of it, that's going to be helpful throughout the semester. We're going to be talking about natural numbers, whole numbers, integers, rationals, irrationals, reals throughout the whole semester. So that's something I would encourage you to kind of get and understand. Thanks, guys.